All right, next thing I'd like to look at is multiple classes. The idea with a class is similar to a struct, and in fact in C++ structs and classes can do almost exactly the same things. But classes are used as a general idea in a lot of other languages as well, so it's important to understand them. The idea is that a class, for example this room CPP file over here and its header, this is kind of a blueprint for if you want to create, in this example, a room object. So this tells you what things a room can do. So it's got a get description. And it also contains some data that is contained within a room, which is this string, and in this example, this vector of exits. If I create a new room, it's going to have all of this automatically within it. Once I have these things, I can actually call them. So if I say create a new room, that calls the constructor, I'll get to that in a second, and I can print it out using get description. All right, there's a few things that have to happen in order to actually use multiple classes. So the first thing is that there's this header file, .h file. So if we look at this, this is the room.h file. So this one has your basic includes, it says your namespace, and it gives you the class name. Inside of this, you say what things are public, which means things that other classes can use and call, and what things are private. The general rule is if someone needs to be able to create something, it's going to call this. This is the constructor. So when I say give me a new room, that's what this is. Notice that it's a special method in that it doesn't return anything. It doesn't have a void or a string or an int or anything. So that special constructor, which has exactly the same as the class, is what happens when you say new room. So over here, it calls this thing. I also have a method which is called getDescription, which returns a string. And then privately, things that people are not allowed to get at, there's actually a description string that's hidden inside of here, but I can't get at it from over here. So if I want to try and get at current's description, can't do that because description is private. This is an idea called data hiding, where you want to try and make sure that you protect the things inside of here. So a good reason for that is, let's say that you have some sort of set description method. Void set description, which takes some sort of string, a new description. If I give it some sort of garbage value, what I may want to do in the set description is check this thing here and see if it's a valid piece of information before I set it internally. So you can do some cleaning up the data that's coming in so it doesn't break your code. If I just directly set it, it's possible that that might screw things up internally in my room. So generally speaking, what you want is getters and setters, or accessors, which are these, and mutators, which are these. I call them getters and setters, which allow you to get at the internal values within a class. And the reason for that is that way you can clean up data coming in. So basically in the .h file, anything that goes in here are either pieces of data that are used or method prototypes. So just the description and parameters. So that's the room.h. The CPP file, so notice this is room.cpp, includes the actual definitions of any methods. And here I have this constructor, room, : room. You need this extra piece in front of here because that says the context of what the room constructor is within. So all of my various classes, or I'm sorry, all of my various methods, room, getDescription, and eventually I need setDescription, are going to need this room : on the front of it. For example, if I'm doing this one, room, : setDescription will happen here. So I could just set it directly, I think, for now, but I probably want to clean that up a little bit before it comes in. So notice here that it has this include room.h, and notice it's in quotes, not in less than and greater than signs. What this does is it basically takes this file here and copies it on top of this one here, so that I'm allowed to use it. Now also notice that up here in the main file, this is my example file which contains my main method, I'm also using a room. I refer to it by using the header file, room.h. So anytime I'm going to use a room, I'm going to include the header file. The idea with the header file is that I could go look at that and figure out all the things I'm allowed to do with a room. The CPP file would actually normally be a compiled thing. It would become a .o object, which would be a binary file, which I actually couldn't look at. So it would actually contain all the implementation hidden away from the user. The user would just know what these things here would do. And in fact, I could even have different people create different object files, CPP files compiled, that did these things in different ways, and that would actually be totally fine. And that's the general idea, is you try and separate the things you're allowed to do with an object, a new one of the rooms, for example, here, and how it actually is implemented. So that's called data hiding, where you actually hide the data away from the user. They just know what things are allowed to do with a room in this example. Okay, so what else can I do with this? Well, actually, how do I even compile this? So the way you compile it is you actually list all of the CPP files all in a row. Or alternately, a shortcut to this is you can do star.cpp. And that will actually compile them all once I actually save everything. Aha, and the room.h file. That's all. So whenever you make changes, you have to save it to all files. So that also works. So that runs my default program, where it actually creates a new room. It calls this constructor here, which does this. So that's the description of default. And then when I print it, it calls getDescription, which is declared here, implemented here, and it just gives it back and coutts it. Some other things that you should know about this: when you're using pointers to objects, they still stick around, just like I mentioned in the pointers video. You probably also want to delete these things when you're done with them. For example, if I'm done with this new room, I don't want this clogging up my memory. You might get a data leak, especially if you're running this for a long time. So you keep creating new objects and not deleting them. So you also want something called a destructor. So a constructor is what you call when you get a new one. What about when I say delete current? So it's valid. That works. But if there are things like, let's say this vector of exits has things inside of it, C++ only deletes kind of the surface level information. So if I call this delete and I have things in my exits vector, it would delete the vector, but it wouldn't delete all the things inside of the vector. So I would probably want something that would actually go into the vector and clear it out. Besides a constructor, there's a thing called a destructor, which has a tilde. And that's the thing that gets called to destroy things. So in here, I'd also need and in here, I would, for example, actually delete all the things from my exits and then delete exits. A natural delete function would actually get rid of the string and the vector because they're not pointers. I can't say delete on something unless it is a pointer. But I would need to do this loop through the exits to delete all the things in the exits before I went through here. All right, so constructors, things that you call when you create a new one. So that gets called by default. Destructors, that gets called when you delete something. Other methods, the prototypes get declared in the .h. So for example, down here, this is the CPP where they actually get implemented. So prototypes, actual functions. And then any kind of fields that you create, you probably want to be private, like so. And that'll actually make it so that your data is protected and someone messing with your file, your room object, won't destroy it. I think that's the basic idea. Hopefully that'll get you started on being able to use multiple files.